to start.
Madison, are you on the freeway right now?
No, I live back up to a ravine.
Oh, cool. I thought you were standing on the freeway. I was like, Madison, you got to get to safer ground. You can't be having meetings on the freeway. Oh, man.
I'm that dedicated to math.
You're that dedicated. You're like, before I run in front of all these cars, I'm going to finish this assignment. Before I run across the highway.
Yeah.
Oh, man.
How did everybody do on the homework?
The first one?
Yeah.
I don't think I've turned it in yet.
Okay.
How did you do?
I haven't turned it in either.
Did you try it once at least? I haven't tried it even once, I don't think.
I've done 8 out of the 10, but there's 2 that I was still trying to figure out before I turned it in.
Oh, okay. I like going. I'm going to sign up probably with the tutor just so I could go over with him. The tutor's like super cool, and he's really good at explaining stuff.
Yeah, he's really nice.
I'm really shocked that they have like a tutor this cool to go. He like sends out that thing where he lets everyone sign up. I met with him on like a Saturday afternoon. I was like, dude, I would never meet with any student on a Saturday afternoon. But I thought that was very dedicated of him.
Yeah.
I was like, man, this guy's cool. I need to be more charitable like him, probably. Oh, man. So I was watching the videos for this week, and do either of you have a problem with falling asleep when the videos go on?
No.
No.
Each time I turn these things on, it's like, oh man, we're live. I didn't know we were live. I thought we were off air still. All right, just kidding. The videos are.
Sorry.
He's all rambling off everything he doesn't like.
Now saying things I do like. Like I like our tutor. He's really good.
I thought you knew we were live.
Yeah, I didn't know we were live. But I did just put in a good plug for our tutor. Because that guy's great. Do you know who records the videos, though? I hope it's not our teacher.
That watches them?
Who records the weekly videos that we watch for these assignments?
I hope
no,
not,
I think
I
it's
hope
like
it's not our teacher just for your sake.
Yeah.
I think it's like communications class or something that does it.
I hope so. I'll feel really bad if it's our teacher. He's like, thanks, Zane. I'm gonna fail you now. No, but to be fair, I have like a short attention span, so I can't sit and watch stuff for like 10 minutes while trying to concentrate on it. And that's kind of what the videos are for me. So.
Can you turn it off, Jorge? When you're done with the water? Quiz.
Is that this week's? Or
Yes. Lesson 7?
Yeah.
Okay, let me open that real quick.
Yeah, I'm working on number 3.
Number 3? Oh, you guys are ahead of me.
I got 0.175.
Hold on. It says find the combined area. So you got to combine the left and the right. You got to shade those 2 sides, right?
Yeah.
So 0.175.
That's what I got.
Is this lesson 7 group meeting quiz? Okay. Sorry. Oh, let's do tomorrow.
1358. Yeah.
Yeah.
Okay.
That's what I got.
We all agree on that one?
Number 3 was
Okay.
0.7 what?
It's 0.175.
175.
0.175.
Yeah.
Which of the following will have a smaller smaller standard deviation if 9 observations are randomly drawn from a population.
I put the distribution of the sample means.
Yeah.
Sounds right, yeah.
Which of the following results implies that the spread in X decreases as the sample size increases?
Which of the following results implies that the spread?
I put the normal distribution, but I don't think that might be right.
I don't know on that one, to be honest.
Because I know the law of large numbers is like it pretty much evens out with so many numbers,
Yeah.
if I understand that correct. And then the central theory is the one we just learned, which I don't think,
That was the last lesson, yeah.
yeah. So I'm like, it's either between the central limit or the normal distribution was what I had thought. Should we go with the distribution?
Yeah, hold on. I'm gonna go ahead and search, but yeah, you guys can keep going. I'm gonna just make sure.
Okay. Okay. Use
For
the
5?
following information for
Oh,
the
wait, for
next 4
5, which one
questions.
did you say?
The normal distribution.
Says Diane earned a score of 160. I hear my voice. On the portion of the GRE.
Whoa.
What is the Z score? Do you hear an echo too?
Yeah.
Okay, that scared me. Thought I was hearing voices for a second. In the shape of my voice. What is the Z score corresponding to Diane's score?
So it's just that same math from last week, isn't it? The
The
You-
thing divided by the standard deviation.
yeah.
You guys are number 6, right? Sorry, I was in the. Yeah, I think so.
So it's just 150.8 divided by 8.8?
No, it
No,
should be.
You have to do a minus.
So it should be 160 minus 150.8
Oh,
over 8.8.
160 minus 150.
So it's 1.045.
But then, okay, so then it has like a square root thing.
Hello, can you hear me?
Yeah,
Oh,
can
did
you
I
hear
cut
us?
out? Oh, yeah, sorry. I got 1.045.
Yeah.
But the z-score, okay, that's what I got, but let me just double.
That is the Z-score. Now, if you're where we got it wrong last time was when it asked like how many got less than that or more than that, then that's different.
Okay, because I like start to freak out when I'm like, this is too easy.
Yeah. So if it says like the standard is 150, who got less than 150, then that's when you use the applet.
Okay.
Like number 7, I think.
Yeah. So then,
Probability that a random selected student would score above 160.
so then we just want to shade this one, the far right one, right?
So on the applet, you got to put the number 1.045.
1.045 for the z-score.
Yeah, and then you just want to shade the one to the right.
Right. So I got 0.148.
Yeah.
Okay. Okay.
Says a random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, 153. What is the z-score corresponding to the sample mean of these students' score? So this one, we have to add all of them up and get the average, right? To get the mean.
Yeah.
So we got 160 plus 175 plus 163 plus plus.
So it should be 160.
Yeah, 160, and then, so it's the same one that we just got up on top, because it was 160. That's what she got. On number 6, she earned a score of 160.
And so it should just be the 1 point. No.
Yeah, it'd be the 1.045. That's the mean. It's
Wait, did you add up? You added up
Okay.
all these numbers or no?
Yeah, so we
Yeah,
added
one.
160, 175, 163, 149, and 153, and then you divide it by 5.
800? Did you get 800?
Yep. Yeah, you get 800, and then you count how many numbers there are.
Divide by 5,
And that's 160.
160.
And that's
And
the
that gives us-
same one as number 6, where she scored 160. And when we did the Z score for 160, it was the 1.045.
Very neat. Number 9, what is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem?
It's the same as number 7.
It would just be
What is
0.14.
the probability of a random selected student will score above 160? Is this asking the same?
It sounds like it. Where's,
Yeah, because I think it's trying to teach us how to find it 2 different ways.
Yeah.
Oh, sorry, 1 second.
Mhm.
it's a very cool ringtone.
Okay. So for the next one, it says, suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of n equals 81 students will be drawn. So number 10 says, what is the shape of the sampling distribution of the random variable x, which represents the sample mean of the 81 students who are selected?
Is it just going to be left skewed?
That was my guess. It's the distribution. It's well known that this distribution is less skewed. Is that like
Sorry.
a trick question? Because it just tells you right there in the question. It is well known that this distribution is left skewed.
Is that what we're going for, is left skewed?
Yeah, I think that's what I just put, is less skewed.
Okay.
The next one says, what is the mean of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population? I don't know. That question just went over my head.
What is the mean of the distribution of the sample means? Would it just be one? No. The mean is 3.5
Mm-hmm.
with a standard deviation of 0.07. That could be drawn from the parent population.
For all possible samples of size 81.
Okay, so okay. I think is that there was a blah 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 formula in the book.
I'm trying to see if I can find the. So
So value minus mean over standard deviation. Is that what we're?
but we don't know what the standard deviation. Oh no, we do. Never mind.
Standard deviation.
But what would be the value? 81? I feel like that's a big number to subtract from 3.5.
Right. Yeah. After finding the z-score. Okay, what about this? Z equals x minus u over O.
That's just, yeah, it's the same thing as the value minus mean.
Okay, so that one's bigger, but find the area. Because I think that's what we want is the z-score, isn't it?
Yeah, but it says here, so on that same one, it says, suppose that a sample size n equals 4. So that we have to find, so then like, we have to divide through the standard deviation over the square root of the sample.
And the sample size is
It's 81, so it's 9. So it's pretty much 0.07, right? Isn't that the, no, 0.7.
0.7,
Divided by the square root of 81.
which is 9.
Yeah, which is 0.078.
Yeah.
So then
So is that the answer?
No. That's just part of the problem, I think.
That's just finding our, that's right. That's finding the next one to find the.
Yeah.
7, 8.
And then
So where did it? Oh boy. This one's different because this one doesn't give us the value. Normally on these problems, they say like, it will be less than, like, what's the probability that it'll cost less than this much? You know what I mean?
Yeah.
Right.
It doesn't give us a number that we can, I don't know.
At least number 13 is what is the probability that the mean GPA for 81 randomly selected students will be less than 3.3.
Well, we need to find the z-score and then we can shade in.
Right. But it's the mean GPA of 3.5. Okay. Five. It is well known that the distribution is
I don't know, guys.
I'm not coming up with anything.
You're what?
I said I can't come up with anything. Not that I can't. I'm not coming up with anything. Trying different numbers. Please. Sorry, I wish the tutor was here.
Right?
Oh, Nathan had class.
Hmm.
Sorry, she's blowing dandelions.
That's awesome.
More dandelions. More dandelions.
I don't know. Do we just use the number 81 then?
Yeah, because that would be N.
No, I mean like as the value, because we're not given any other number.
Are we still using the equation value minus mean over standard deviation?
Yes.
Yeah.
Yeah.
And we're trying to solve because we don't have the value, or we're trying to figure out what the value is.
Yeah.
Is the mean was the 0.078, correct?
No, the mean is 3.5.
3.5. What was the 0. Where did I get that number from? The 0.078?
That number is the so you have to in the book, as it said, the problem is you have to find x, and x is the standard deviation divided by the square root of the number of samples.
The 9. Okay.
And so that's how you got the 0.078.
Got it.
Okay, I'm getting 0.078
Yeah, that's for the
standard deviation.
Yeah. we're still stuck on number 11.
Oh, and I think number 10 is approximately normal.
Approximately normal.
Yeah.
Okay.
So okay, so for the 12, then we would just put the 0.078.
That's what I think.
Right? That's the standard deviation.
Yeah.
0.078.
So we still need number 11 and 12, 13, 14, 15.
Right.
Let's see.
Okay, so now we can do number 13 though, because we have a value.
Right.
Because on number 13 it says that will be less than 3.3. So then we can do the 3.5 minus 3.3.
Just 0.02 or 0.2.
Yeah, and then you got to divide that by the
0.7.
yeah.
0.29. No,
But
0.26.
question. Hold on. Hold on. I think it's divided by the 0.078.
2.56. Wait, what?
Because so if you look at the problem, if you look at the book, it says that it's x minus u, which is the value minus the mean, so 3.5 minus 3.3, over deviation divided by the square root of the sample of 81. We already know that the deviation divided by the square root of 81 is 0.078. So then it's just the 3.5 minus 3.3 divided by that number that we came up with. So if you go to the applet and you put 2.56
5, 6.
and you're trying to find what is the probability that it'll be lower than that, you get
Greater.
0.99.
0.005.
0.995.
No.
No, because you want it to be at the bottom left one.
Yeah, so yeah, 0.005.
Okay.
Less
I think it's the middle and the left, because, oh, maybe I'm wrong. I don't know. I'll just put 0.005.
Got 2 tries.
Yeah. Okay, what is the
So what is-
probability that
Greater
is
than,
greater? So then you just shape the other side.
which is the same, but
Yeah.
wouldn't. Yeah, so we just want the 0.5, not the 0.99, right?
Yeah, just the 0.005.
0.05. Yeah. 5 is
Number
13.
The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weighs is 26.7 pounds. The weighs of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is extreme or more extreme than was observed in this sample. So I just got 0.040. I don't know what that's like.
How did you get that?
Hold on, give me 1 second. I'm just double checking before I say anything. Okay, so what I did was, so your value is, hold on. So I just used the value and the mean as the 185 and the 177.6.
Yeah, subtracted from each other.
Yeah, and then over the standard deviation, which is 26.7, divided by the square root of 48, which is the number of passengers that were used. And yeah.
Okay. And what was it that you got?
So for the first one I got, so it would be 7.4, 185 minus 177.6.
Right.
And then I did the separate math of 26.7 divided by the square root of 48, which is 3.85.
Ish, yeah.
So 7.4 divided by that, I got 1.92.
I got 1.917.
One point nine. Yeah, but you have to round it up to 1.92, no?
It wants 3 decimals.
Okay.
So yeah. So this one.
Well, okay, so I used the whole big, okay, I'm confused on this one. Okay. I just used the whole big number. So in reality, it would be like 7.4 divided by 3.853813. It went on forever. So when I divided that big whole number, it came back up to 1.920. So I don't know.
Okay. Yeah, let me try it again from the big. Because I kind of like break it down too.
Yeah, so I didn't round it until the
The end. Okay, so let me do this again. Oh no.
Dane, are you good? You're kind of quiet.
Yeah, for a period there, my computer actually cut out, so that's why you didn't hear me for a little bit. And then when I came back, I didn't want to interrupt you guys because you were talking back and forth.
Oh.
But I am still alive, if that's what you're asking.
Divided by 7 divided by square root. No. No. Shoot. Okay, I'm just gonna do it on my phone because.
Just remember that you're using your phone to put like the double parentheses on the bottom.
Right. Okay, yeah, you're right. 1920.
Hopefully, that's right. I don't know.
1.920.
Okay, but now we gotta go back up to number 11.
What'd you get?
Yep.
What'd you get for 14?
0.005.
1.005?
No.
Not one. That's the point.
All these
Oh,
flowers
0.005.
for you.
Oh, honey, I don't want them right now, but thank you. Give
Wait,
me
was that
just
the same thing as for 13? I got.
Yeah.
No, don't stop, please.
Why?
Okay.
No.
But
I don't want them in my shoe, please.
why?
What is the mean of the distribution of the sample means for all possible samples of size 81?
What is the?
I don't know.
The mean of the distribution of sample means is called the expected value of M and is always equal to the population mean U. The standard deviation of the distribution of sample means is called the standard error of M. Okay. If a population has a mean of the U, then the mean of the sampling distribution of the mean is also U. So
wait, repeat that. So if the what is U, then what equals U?
So the sampling distribution of the mean is the population variance divided by N. The number of scores used can compute the mean. Hayes, can you turn the water off, please? The mean of the distribution of sample means is called expected value and is always equal to the population mean.
Hmm.
So I still didn't get that. What do you?
Glad I'm not the
I don't
only
know. I
one.
thought reading it would maybe help us understand. I have no idea.
Yeah. Should we just put 0 and hope that when we turn it in, that's the right answer?
I don't think it'll be 0.
It's my best guess at this point.
For all the samples, possible samples, could be. What is the mean of the distribution of the
The
sample
reading
mean?
wasn't that much. I feel like we should be able to find this out.
I know, with the reading being this short.
So let's see. Probabilities involving a mean.
Sample mean is normally the short.
No one don't. I wonder, do we just use 1, you think?
Use 1 for what?
As the value?
Part of my shovel broke it.
Why do you think that? Because if the
I'm just
mean
looking
and
in
this
the book.
that is, it has a mean of 0 and a standard deviation. To this. Oh yeah.
So we just gotta calculate the z-score with no value.
So are you using 1 as the value?
No, I'm trying to see. I'm still trying to find out how you can calculate the z-score without the value.
Have either of you signed up for tutoring this week or no?
Say that again.
Either of you signed up for tutoring for this week? Tutoring?
But no, I haven't.
No. I think I'm going to be signing up.
Can I say hi?
No.
Because I'm not in class. Because I'm really not in class. Hi.
Hello.
So
Take
I
it
don't
away.
know, guys. I'm completely lost.
Should we just submit what we got?
Well, we want to put a guess in there at least, because then.
That
I'm
was
gonna
my
put
0 that
043.
What?
043. 8.043.
Wait,
Madison.
that one. How'd you get 0.43?
Because I
don't know.
divided 3.5 by 81.
You divided what?
I did 3.5 divided by 81. I know it's incorrect, but I don't know what else.
0.043. Guess that's better than my 0 answer.
Wait,
Okay, you want to go ahead and let's go ahead and submit this and see.
okay.
Go to submit. Someone have it yet? I'm submitting mine.
Oh, I was going to do it. You want to do it?
Oh yeah, 64 out of 71. Oh no, 64.71. 11 out of 17.
Oh boy.
Hi, Chihuahuas. So 15's wrong, 14's wrong, 11's wrong.
Well, 11, we kind of knew that one. 11, 14, and 15?
Let me see. Let me go up again. 5's wrong. I'll go down. 5's wrong. 8's wrong. 9's wrong. 11's definitely wrong. 14's wrong. And 15's wrong. Well, we got 6 wrong. Oh, we didn't fit.
Okay, so let's start from the top. So number 5 is wrong.
Yep.
And it said, which of the following results implies that the spread in X decreases as the sample size increases?
So then is it going to be the central limit or law of large numbers? I'll do the central limit and then I'll submit this.
Okay, number 8 is wrong too, right?
Yeah.
Yes. 8 and 9, yeah.
What the heck? I'm so confused.
Yeah, because I thought I was pretty confident on that one.
Yeah, because it's just 160. That was the mean out of all 5 is 160.
Maybe I can sign up for a tutoring session, and then because this isn't due till tomorrow, and then I could have.
I think 5 is the law of large numbers.
Whitney's already here.
Yeah, Whitney is here.
Hi.
Do you think it's the law of large numbers?
And number 5 is. So I read about that.
Okay.
But I don't know the other ones.
Should we just do that and then?
Yeah, I mean, I'll probably go over the second part with my tutor. I'll see if I can sign up for a 2-hour tutoring session.
Yeah, I'm gonna keep figuring this out, and then if I get anywhere, I'll let you guys know.
Okay.
Okay, I think it's the same. I'm gonna try working on it. I've got to go here soon, but I'll get back to you guys sometime tonight.
Yeah, put 5 for 5, put law of large numbers. I'm 99% sure that one's right.
So wait, just in case. So we got 5, 8,
Yeah.
8,
11,
8, 9, 11,
14, and 15.
14, 15, yeah.
5, 8, 9, 11, 14, 15. Okay, thanks, guys.
I texted
welcome.
everybody the numbers we missed.
Okay.
All right, sounds good. All right, adios, everyone.
Okay,
Thanks.
thank you.
Yeah.
Bye.
Bye.
All right, concludes lesson 7.